In this video, we will discuss integration by parts. Integration by parts is another technique of integration that, like the method of substitution, is based on a corresponding rule of differentiation. In this case, the rule of differentiation is the product rule, which tells us that if f and g are differentiable functions, then the derivative of f of x times g of x is equal to the derivative of f of x times the derivative of g of x plus g of x times the derivative of f of x. If we integrate both sides of this equation with respect to x, we obtain the integral of the derivative of f of x times g of x dx is equal to the integral of f of x times g prime of x dx plus the integral of g of x times f prime of x dx, which is equal to f of x times g of x, which gives us f of x times g of x equals the integral of f of x times g prime of x dx plus the integral of g of x times f prime of x dx. We rewrite this last equation in the form the integral of f of x times g prime of x dx equals f of x times g of x minus the integral of g of x times f prime of x dx, which is the formula for integration by parts. Integration by parts is useful because it enables us to express one indefinite integral in terms of another, which may be easier to evaluate. We can simplify the formula by letting u equals f of x dv equals g prime of x dx, du equals f prime of x dx, and v equals g of x. The integration by parts formula is the integral of u dv equals uv minus the integral of v du. Evaluate the integral of x e to the x dx. No method of integration developed so far lets us evaluate the given indefinite integral in its present form, so we attempt to write it in terms of an indefinite integral that will be easier to evaluate. Let's use the integration by parts formula by letting u equal x and dv equals e to the x dx. Then du equals dx and v equals e to the x. Therefore, the integral of x e to the x dx is equal to the integral of u dv, which is equal to uv minus the integral of v du, which is x e to the x minus the integral of e to the x dx, which is x e to the x minus e to the x plus c, or x minus 1 times e to the x plus c. The success of the method of integration by parts depends on the proper choices of u and dv. For example, if we had chosen u equals e to the x and dv equals x dx in the example, then dx equals e to the x dx and v equals 1/2 x squared. We would have wound up with the integral of x e to the x dx equals the integral of u dv, which equals uv minus the integral of v du, which is 1/2 x squared e to the x minus the integral of 1/2 x squared e to the x dx. Since the indefinite integral on the right side of the equation in the previous slide is more complicated than the original integral, choosing u and dv as shown has not helped us to evaluate the given integral. In general, we can use the following guidelines. Choose u and dv so that 1, du is simpler than u, and 2, dv is easy to integrate. Evaluate the integral of x ln x dx. Let u equal ln x and dv equal x dx. So du equals 1 over x dx and v equals 1/2 x squared. Then the integral of x ln x dx equals the integral of u dv, which is uv minus the integral of v du, which is equal to 1/2 x squared times the natural log of x minus the integral of 1/2 x squared times 1 over x dx, which is 1/2 x squared times the natural log of x minus 1/2 times the integral of x dx, which gives us 1/2 x squared times the natural log of x minus 1/4 x squared plus c, which is 1/4 x squared times 2 times the natural log of x minus 1 plus c. Evaluate the integral of x e to the x over x plus 1 squared dx. Let u equal x e to the x and dv equal 1 over x plus 1 squared dx. So du equals x e to the x plus e to the x dx, and v equals -1 over x plus 1. Then the integral of x e to the x over x plus 1 squared dx is equal to the integral of u dv, which equals uv minus the integral of v du, which is x e to the x times negative 1 over x plus 1 minus the integral of negative 1 over x plus 1 times e to the x times x plus 1 dx, which equals negative x e to the x over x plus 1 plus the integral of e to the x dx, which gives us negative x e to the x over x plus 1 plus e to the x plus c, which equals e to the x over x plus 1 plus c. In some cases, we may need to use integration by parts more than once to evaluate an integral. Evaluate the integral of x squared e to the x dx. We let u equal x squared and dv equal e to the x dx. Then du equals 2x dx and v equals e to the x. So the integral of x squared e to the x dx equals x squared e to the x minus the integral of e to the x times 2x dx, which is x squared times e to the x minus 2 times the integral of x e to the x dx. To complete the solution, we need to evaluate the integral of x to e to the x dx. We have already found this integral in the first example of this section. The integral of x e to the x dx equals x minus 1 times e to the x plus c. Using this, we now find the integral of x squared e to the x dx equals x squared e to the x minus 2 times x minus 1 e to the x, which is e to the x times x squared minus 2x plus 2 plus c. The integration by parts formula is easily adapted for definite integrals. The integral from a to b of u dv is equal to u times v evaluated between a and b minus the integral from a to b of v du. Evaluate the integral from 0 to 4 of x times x plus 5 to the negative 1/2 dx. We let u equal x and dv equal x plus 5 to the negative 1/2. So du equals dx and v equals 2 times x plus 5 to the 1/2 power. Then a equals the integral from 0 to 4 of x times x plus 5 to the negative 1/2 dx, which is x times 2 times x plus 5 to the 1/2 evaluated between 0 and 4, which minus the integral from 0 to 4 of 2 times x plus 5 to the 1/2 dx, which is 2x times the square root of x plus 5 evaluated between 0 and 4 minus 4/3 x plus 5 to the 1/2 evaluated from 0 to 4. Which gives us, that should have been 4/3 x plus 5 to the 3/2, not to the 1/2. That gives us 2 times 4 times the square root of x plus 5 evaluated between 0 and 4 minus 4/3 times x plus 5, should have been 2 times 4 times 4 plus the square root of 4 plus 5 minus 4/3 times 4 plus 5 to the 3/2 minus 5 to the 3/2, which is equal to 24 minus 4/3 times 27 minus 5 root 5, which equals 4/3 times 5 root 5 minus 9.